Are we recording for anybody else besides Aubrey? Is everybody here? What? Aubrey? We are doing the second half of 5-3. Okay? 5-3 today. 5-4. I kind of warned you yesterday that 5-4 is going to be very similar to 5-3. It's just two different ones. Right? So this one is side, 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 and side, angle, side. We're going to talk side, angle, side today. Okay? So you need your yellow sheet. We're going to add those two on here. If you haven't written everything down, we are like 4 lines down. So start on the 5th line. And we're doing side, 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 and side, angle, side. Okay? Side, 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 angle, side. If you need, do we need to write down what those mean? Like, do I need to write down side, side, side?
One of those is what Comey has.
Side, 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 angle, side. Okay, there you go.
That's what I was thinking. Oh, no, I was not.
Okay, there we go. Put your foot down. Thank you. You can move that chair and put your leg up.
SSS assassinator, sorry.
Like, put your leg up on the chair. Okay. Side, 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 angle, side. All right, those are the two that we have to write down. I'm going to draw a picture, a couple pictures. Let's just draw the same picture. I'll just draw like this. And we'll do the same thing for the bottom one. Shush. Perfect. We got some stuff going on. All right, the whole purpose of this section and the next section is to prove that those two triangles are congruent. Congruent means what? Same shape, same size. Those two things have to be checked out, right? If they're the same shape but different size, like circles that are different size, right? Those are similar, not congruent. We want same shape, same size, all right? I want to prove that those are the same shape, same size. In the past, or in section 5-2, I would have to go through all of the angles and say angle A is congruent to angle D, angle B, blah, 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 blah. I'd have to do all 3 angles. Then I'd have to turn around and do all 3 sides, right? Like side whatever, side AB is the same as side DE, side BC is the same as EF, AC is the same as DF. That involves me doing 6 different things, right? I have to check off 6 boxes. All 3 angles have to match, all 3 sides have to match, then I know they're congruent. Now, as of yesterday, we get to do a shortcut, which says if I'm able to prove that this side matches this one, and this side matches this one, and this side matches this one, then I don't even have to look at the angles because the angles have to match, right? If all 3 sides over here match all 3 sides over there, the angles have to be the same. Like, there's no way around it. So I don't even have to discuss the angles because by the side, side, side theorem, those two triangles are congruent. I don't even have to look at the angles. True? Yes? Okay, so I'm going to say over here in my, like, story area, right, that if AB is congruent to DE, BC is congruent to EF, and what's the last one? AC is congruent to DF. If that is true, by side, 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 triangle ABC is congruent to triangle DEF. Has to be. They have to be the same, even though I didn't even discuss the angles. They have to be the same, as long as the 3 sides are the same. Now, before we do the next one, let's talk about some other things. Let's say, because the next one is side, angle, side, right? Let's talk about angle, angle, angle. Let's do the AAA, right? Okay? If we do AAA, right? Like, does AAA behave the same as triple S? Like AAA, is that the same thing as SSS? Right? Let's say I have a triangle. This is an equilateral triangle, which means all the angles are 60s, right? 60, 60, 60, right? And let's say this is 5 inches, this is 5 inches, this is 5 inches. Those angles match this equilateral triangle, which is also 60s, but these are 7s by 7 by 7. technically there, all of the angles match all of the angles, right? The angles from there match the angles from there. But are those two things congruent? So AAA is not a way of telling that two triangles are congruent. SSS is, but AAA is not, right? Another one that you guys talked about yesterday was like ASS. I'm going to write it on the board. Don't write it on your paper because we're not even going to talk about it, right? ASS is angle side side. ASS is angle side side. I'm going to show you later why that doesn't work, but that is not one that also works, right? In the same way AAA does not work. All right, get it off of there.
Oh, come on.
Oh, come on.
Oh.
Our teacher wrote that word in all caps.
I'm going to write in all caps. Okay, anyway, but we'll talk about it later. Again, like we'll probably talk about it Monday, why that thing does not work, and I'll show you diagrams of why that doesn't work, okay? But the next one is side angle sides. So, again, going from 6, all 3 angles, all 3 sides. I don't want to have to do all 6 things. I don't want to have to check out all 6 things. So I can either check 3 sides and 3 sides, right? Like do the sides, right? Or I can do side angle side. But here, there's some specifics as far as side angle side is, okay? Here we go. If I say this side, let me go a different color. If I say this side matches this one, and this side matches this one, the angle that has to match has to be the angle between them, right? Otherwise, if I say this angle right here, that's ASS, right? That's angle side side. The angle is not between the two sides. This is ASS.
Beef chicken.
That's ASS. This is side angle side. Do you see that? Side angle side. So when you do side angle side, there are 2 sides. The angle that has to match from one to the other has to be the angle between the 2 sides. Got it? Okay? So this is how this works. If I am able to say that, I don't, just wait a second. Put your hand down. If that stuff matches this stuff, I don't even have to talk about this side versus this one. I don't have to talk about this angle in comparison to this one. I don't even have to talk about this angle in comparison to this one. By default, if this matches this, this matches this, this matches this, those other blue ones have to match. They have to. I don't even have to discuss them. They have to match. Got it? So I get to reduce down my workload from going to talking about all 3 angles, all 3 sides, which is 6 things that I have to check off, to now only having to check off 3 things. My proof goes down like in half. Got it? Okay? So here we go. If AB is congruent to DE, let's say BC is congruent to EF, and what else? Angle B is congruent to angle E by side angle side. Triangle ABC is congruent to triangle DEF. Okay, I only have to check those 3 boxes instead of all 6 boxes. Got it? That is how that works. Side, 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 side angle side. Okay? Good? I'll give you a second. This is such a huge Dr. Pepper bottle. I've been working on this for like 3 days now.
That's disgusting.
Well, I know, it's not as like fizzy as it was before. So it's not as great. It's kind of flat, but whatever. Anyway, whatever. Okay, all right. Let's do some examples. Here we go. We are now on. Let's go to example 3 and then we'll bump back to example 2. Okay? Example 3, we'll bump back to 2. Here we go. Okay? This is using side angle side, SAS. It tells you. Use SAS. All right, here we go. Do you see, I don't know if you can see very well, on your diagram, which 2 triangles we're trying to prove are congruent? Like this guy right here and this guy right here. Just those 2 little pieces, okay? We're trying to show that those are the same shape, same size. We're given some things. We've got to find some things and all the stuff, all right? 2 column proof. They will always be congruent. You have to prove why. Good question. I'm sorry. All right, so we always do 2 column proof. We start with statements, reasons. On the homework assignment, they will ask you to do like a flow proof or a paragraph proof or
What did you give us?
some other weird. These are 2-column proofs. We will only ever do 2-column proof style. Okay? So statements on the left, reasons on the right. All right. They give you this information right here. So I have how many pieces of given information do I have? 2. Starting with this guy. KL is the same as LM. All right, they say given. That's my first thing. Okay, let's mark some stuff on here. How can I show on this diagram that KL and LM are the same? Do a little tick. So actually mark it on your diagram. KL, LM, put a little tick mark. Go. I started teaching proofs this way like 3 years ago, and it has helped significantly. I do an inventory on this left side, and it helps a lot. So as far as my inventory goes, after line 1, what do I have? I have a side. Okay? So I'm a third of the way done, and I'm just using what's given to me already, right? The second piece of given information is this guy. They have it written down right here. What do I put in this blank? Given. Okay? And let's talk about those. It says angle JLK. Which one's angle JLK? This one right here. Okay? Is congruent to angle JLM. Which one's JLM? The same one right below it. Okay? So those two angles are the same. All right, I know they're the same measure. Okay. Now I have in my inventory an angle. You're about ready to get moved, boys. Shh. All right. Now, I'm done with my given. That's the hard part. Like, now I have to actually do something, right? Like, I have to work hard for the last thing. So I know that I have a side and I have an angle, which means I need another side because they tell me I'm doing side, angle, side. I need another side. So I just have to look at the diagram to figure out what the third side is. Hey, JL is the same as itself, right? Because they're touching. Like, that's got to be the same. JL is congruent to JL. Okay? And that is we learned yesterday that is the reflexive property. Reflexive property. That wasn't too hard to work for. In my inventory, I have another side. So, are those two triangles congruent? Because I didn't say anything about JK being the same as JM, right? And I didn't say anything about angle M being the same as angle K. But I don't have to, right? Because they have to be the same as long as side angle side is the same, right? So, those two triangles are congruent because of side, angle, side, right? This is usually how most of the proofs work. You will usually be given some pieces of information, and then you'll have to solve some pieces of information on your own, right? Okay, got it? Sometimes, I'm just going to give a little hint here, sometimes your triangles will be positioned like this, okay? I cannot use the reflexive property, but the way that those triangles are positioned, I can find that something is the same. These two angles are the same. So now this middle piece is not the reflexive property that I have to generate. Now I'm probably going to use vertical angles, right? Because that's how they're positioned. I know that those two angles are the same. So sometimes if it's positioned like that, you'll use vertical angles instead. Got it? Okay? All right, let's go back up here to example 2, and then we'll be done. This is kind of a pain in the butt, but it's fine. Whatever. Okay? Use side, SSS, to prove that those two triangles are congruent. You're going to really not like this very much, but that's okay. All right, let's plot them. J is 2, 5. I mean, you don't have to, but let's do it. J, okay. K is 1, 1. L is 5, 2. J, K, L. Whoop. Yes.
Can't you just, like, if the distance between the points are all the same, can't you just do that?
Yeah, we're going to find the distance between each point.
Oh.
Oh, which means we have to do the distance formula. Okay.
No, I mean, like.
Okay.
I mean,
Like eyeballing it? I'm not a good eyeballer.
Like J and K, it's 1 and
We should only have to do it
4.
one time.
Sorry.
Or one time for each.
And Q and N is 1 and 4. Can't you just say that's, you know what I mean? Yoda yang?
Kinda, maybe. We're trying to show, maybe, if those two triangles are congruent. I'm not really sure.
I'm gonna go with, yeah.
Yeah.
Well, like, Q and N and J and K are the same, right?
Maybe.
Yeah, they are.
You can just look at it.
So they want you to do this by doing the distance formula.
I'm not
Let's
doing
do
that.
the distance formula. I'll write it down. You don't have to write it down. You don't have to write it down. I will do the work for you. You can sit and watch. Okay? And then we'll talk about shortcuts, okay? All right. So, let's do JKL first. Let's do the first one first. Okay? So, give me a side. JL. Okay. Another side. I'll list them all out. LK. Third side.
JK.
JK. Except not really. Right?
Just kidding.
Just kidding. All right. Distance formula. You take the square root. Square root, square root, square root. And I do this guy squared, this guy squared, this guy squared. This is a pain in the tushy.
That's why I'm not gonna do it.
I told you you could just sit and watch. It's fine. Just sit and watch. Just be patient. Okay? All right. Uh-huh. 2,5. I'll show you how to cheat. It's fine. I'll let you cheat. It's
I
fine.
know how to cheat, believe me.
Just wait. And K is 1, 1. All right, there you go. Okay, so if we're doing JL, I'm doing the distance between these two. So I'm looking at the x coordinates. How far apart is 2 and 5? 3. How far apart is 5 and 2?
3.
Also 3. Okay, 3 squared is 9. 3 squared is 9. 9 plus 9 is the square root of 18. That's that side. I don't know what that is. We're just going to leave it as the square root of 18.
Well, let me look for you.
Next.
About 4.
Next, we're going to do these two. How far apart is 1 and 5? 4 and 1 and 2?
2.
1 and 4 squared is 16 and 1 squared is 1 and this is the square root of 17, right? Square root of 17. Okay. Last one is JK. How far apart is 1 and 2? 1. How far apart is 1 and 5? 4. So this is 1 and 16. So that is the square root of 17. So this is a what kind of triangle actually? It's isosceles. 2 of the sides are matching, yeah? Okay. Next. Blue. Okay, give me the sides of your blue one. K, what? QN? QN. Next.
So it is a thing now.
NP. Next. PQ. Okay. Square root, square root, square root. This guy, this guy, this guy, this guy. Okay, there we go. All right. Let me write my coordinates down. Hold on just a second. -4, 4. You just hush. I'm doing all the work for you. Don't even moan and groan. Don't even moan and groan. You just be quiet. Okay, because if anybody's going to moan and groan, it's going to be me. All right. Okay, we're going from Q to N. Oh, gosh. Q to N. How far apart is -4 and -3?
I don't know. You tell me.
No, not 7. 1. Okay. How far apart is 4 and 0? 4. And that's the square root of 17. But hold on. That doesn't match this guy. Shouldn't my first one here match my first one there? Not necessarily because they could be rotated. All right. Here we go. Next one, NP, is this guy. I'm looking at -7 and 3. -3. 4 and 1 and 0. That is the square root of? Oh, it's looking good so far. I know at this point that this triangle is either isosceles or equilateral, right? Okay, the next one right here, -7 and -4. 3 and 1 and 4 is 3, and we know from above that that is the square root of 18. So, are these two triangles congruent? Yes, they are congruent because of side, side, side. All 3 sides match all 3 sides. Okay, now, I get it. You don't want to do all that work. Whatever. Okay, so let's talk how this works here. Okay, let's talk how this works here. Okay, so this side, if I'm going to talk about QN, he goes over 1, down 4. Do we have another one that goes over 4 and up 1 or over 1 and 4, right? JK is a 1 and 4. Got it. Those match. Also LK, okay? So we're matching 1 for 1. So we know that this matches that guy, right? Or we could do that guy matches that guy. Doesn't matter, right? Just 1, okay? This guy is a 1 and 4 also. Do we have another one that's a 1 and 4? Yep, 1 and 4. So that guy matches that guy, right? But this one, this third one, is a how much and how much? Is a 3 and 3. That's a 3 and 3. So those guys have to match, right? Okay? So because of that, all 3 sides match all 3 sides. Got it? Okay?
But
Yes,
did you
good.
understand what I was saying?
What?
Shog's district is just like everyone else.
Gallery County.
Like J and K are 1-4 apart.
Yes, that's what we
I
just
know.
did,
Oh.
child. JK is a 1-4, so is QN is a 1-4. This is a 1-4, and this is a 1-4, and this is a 3-3, and this is a 3-3. So yes.
Can we do number 8 together on home?
Now, here's the deal. You ready?
It's no.
Listen, hold on. So my way, by doing this over here,
I'm not doing
you don't have to draw them.
good.
This way, you have to draw them. So which one? Pick your poison.
You don't have to draw.
You go for then you go for it, right? So it's gonna be.
You don't have to draw.
You can't do this in your head.
Yeah, you can.
Okay.
I mean, I don't know. I would still write it down
The
though.
way I was
Like
explaining
doing it in your head is basically doing this. You might as well just write it down if it's in your head, right?
That's simpler for most.
Whatever. Okay, there you go. Good?
Number 8 on the homework together, please.
No.
Did
You can do number 8 on the homework.
Right now it's no. Did you already do it?
No.
Okay,
It's in
if
my
you
head.
put no or yes and don't justify, even if it's right, I count it wrong. You either have to graph it and show me, or you have to do all the distance formulas. I don't care either one, but you cannot just put yes or no. I will count it wrong no matter what. This is your one and only warning. 8 and 10.
Warning.
Grafted on the graph on like the
What
Oh,
if I didn't-
crap.
What if I didn't graph it? What if I just made triangles and drew sides?
But Jack
Just
said,
come take a look. It's pretty beautiful.
You have to put something down,
I put
not just yes or no.
3,
just doing distance.
oh my gosh.
0.
Come bring it to me on all initials saying Mrs. Cometer has checked it.
Okay. Well, I'm not done with 10 yet.
There we go.
Okay.
4,
I'm doing them
0.
here and here.
Okay, fine.
Rather do it on the
Mrs.
iPad.
Cometer has checked.
Wait, so we just have to do what you did again, but twice?
Oh my gosh, Mrs. K, okay.
I don't have it.
Mrs. K, okay. All right,
Thank you.
there you go.
Can I see that signature?
Show me, Owen.
Ah. All right, there you go. Oh gosh, we're still recording. Bye, Aubrey.
Bye-bye.